Good evening, everyone. Thanks for joining the ITRI MMSL 2025 Intelligent Mechatronics Online Forum. We're delighted to have you with us. The theme of this year's forum is Next Generation Intelligent Mobility and Manufacturing. The event will explore the latest innovation shaping the future of vehicles and robotics. Now let's take a look at today's agenda. As shown, today's agenda includes 3 10-minute speeches. During this time, the QR code for our survey form will be shown on the screen. Please take a few minutes to fill it out, as your feedback is important to us. If you have any questions, please feel free to leave comments. We have also shared a link to the survey form in the description below. For those who are unable to stay with us throughout the event, please let us know your feedback. We will share today's presentation files upon receiving your feedback. Great, let's get started. Let's welcome Dr. Peng Yang, Deputy General Director of ITRI MMSL, and Dr. Mingze Wang, International Affairs Officer and a representative of ITRI International Office in the United States, to deliver the opening remarks.
Esteemed participants, a warm welcome to today's online forum. My name is Peng Yang, Deputy General Director of Mechanical and Mechatronic System Research Laboratories, or MMSL, at Industrial Technology Research Institute, or ITRI, in Taiwan. We are delighted to have you join us as we embark on an exciting journey into the world of intelligent mechatronics and its transformative impacts on manufacturing. Rapid digital transformation, automation, and artificial intelligence are reshaping the manufacturing industry and beyond. They drive faster, more connected, and sustainable operations from factory floors to transportation systems, empowering industry to enhance productivity, efficiency, and safety like never before. Throughout today's forum, we will highlight research and development capabilities dedicated to addressing current industry challenges and advancing flexible manufacturing systems through state-of-the-art technologies. We will see how our intelligent manufacturing and mobility-related technologies make this evolution of the industry possible. I welcome you to ask questions below. Your contributions are invaluable, and we believe that diverse perspectives will lead to innovation and potential collaborations. Before we begin today's agenda, I would like to welcome International Affairs Officer and representative of ITRI International Office from the United States, Mingze Wang, for a few words.
Thank you, Peng Yang, for the kind introduction and this opportunity. Good morning, everyone. My name is Mingze Wang, and I serve as the International Affairs Officer and the U.S. representative of the ITRI International Office. It's a real pleasure to be with you today. This event represents an exciting opportunity to connect with the experts from ITRI's MMSL, leaders in intelligent mobility and robotics. These cutting-edge technologies are at the forefront of global industrial transformation and represent a strong foundation for collaboration between Taiwan and the United States. As one of the world's leading applied technology research institutes, ITRI is home to more than 6,000 top-tier researchers. Our mission is to drive industrial innovation, create economic value, and improve quality of life through technology innovations. We actively anticipate future needs and deliver impactful solutions that respond to global challenges such as urbanization, demographic shifts, sustainability, and climate change. In my role at ITRI, I'm proud to work with a talented team dedicated to bridging U.S. innovation ecosystems with Taiwan's smart manufacturing and supply chains. Through ITRI's global collaboration platform, we aim to foster long-term, mutually beneficial partnership that span borders and industries. I look forward to the meaningful connections and conversations that will take place today and the continued collaboration between ITRI and all of you. Thank you.
Thank you, Dr. Yang and Dr. Wang, for your warm welcome. Next, we would like to invite Dr. Yang once again to provide us with a quick glance at Mechanical and Mechatronics System Research Labs.
Hello, my name is Peng Yang from Mechanical and Mechatronics System Research Labs, or MMSL, an Industrial Technology Research Institute, or ITRI in Taiwan. In this presentation, I am going to give you a quick overview on the capabilities of enabling future smart manufacturing and vehicle technologies. MMSL consists of more than 500 employees, with the majority of them are researchers with master or doctoral degrees. We have more than 1,500 active patents. Our aim is to provide technologies to enhance the intelligence, precision, and green for the industry. We have two major areas. One is intelligent manufacturing, covering robotics, intelligent factories, and also key modules or equipment for the semiconductor industry, and green technologies for different types of industries. The other one is for intelligent mobility. We develop electric and new energy vehicles, autonomous driving technologies, unmanned aerial vehicles, and also railway systems. For the intelligent factory, so we try to connect equipment and materials together with Internet of Things. We also have sensors integrate with our algorithm to quantify the status of the equipment. Then we can connect the equipment together with the parameters. And we also incorporate AI technologies in different stages of manufacturing to control the quality of the product. To integrate all of this, that we can have the manufacturing process smarter. Here is an example. Now we try to integrate systems into a 3D composite braiding system. As a world trend of low carbon or zero carbon emission, we try to reduce the energy consumption in different manufacturing processes with different strategies. The first one is to provide high efficient motors that can be used in different stages of manufacturing, and also low carbon thermal management systems with the energy storage applications, also such as the high-speed flywheel technologies and also superconductor technologies. We also developed new low-carbon, high-efficiency manufacturing processes. Here is an example.
Sinmat microwave annealing technology is a result of a tripartite collaboration between ITRI, National Jiao Tong University, and National Nano Device Laboratories, can process multiple wafers at one time and can effectively control the heating range to avoid thermal diffusion. The technology saves a great deal of time and energy compared to rapid thermal annealing. The frequency of the microwave tubes used in the new technology is 2.45 gigahertz, the same as that of a typical domestic microwave oven. A 2.45 gigahertz magnetron costs only about 1/10 of the price of the 5.8 gigahertz high-frequency microwave magnetron currently used by manufacturers, while its average lifetime is 6 times longer, which greatly reduces maintenance costs.
As you might know that Taiwan is famous about semiconductor manufacturing. We also have a division dedicated to these technologies. So we use multi-physics simulation in different stages of the manufacturing process, such as the plasma etching or deposition and wave process for advanced packaging. And we also provide grinding polishing equipment that can be used in different materials, including the optical components. We also integrate low fluoride or low carbon equipment in different industries for green technologies.
The following is the principle of the hybrid ALD equipment. The vertical flow field is simulated by multiple physical coupling methods into the 12-inch process chamber through the aeration module, and the special aeration hole design is used to improve the uniformity of the overall chamber flow field. Place the cassette into the wafer loader. System parameter confirmation. By adopting the crossover flow multimodal ALD technology, the thermolysis and plasma bias dual mode is used to enhance the collimation of deep hole coatings, thereby improving the compactness and deposition selectivity of the film layer, achieving multi-composition, high-step coverage, and uniform coating deposition. The robot arm removes the wafer from the process chamber and transfers it to the discharge chamber.
To combine the different manufacturing processes, we need robotic technologies. Over the past 20 years, now we have developed different types of service robotics, industrial robots, AGV, AMRs. We also apply that into different fields, including the surgical fields. We recently have international collaborations with many European countries on the handling with AI-enhanced robotic technologies for flexible manufacturing. That's for manufacturing. Now for mobility, now we developed technologies to fulfill the needs for electric vehicles, from fast charging station, onboard charger, battery pack, energy management systems, vehicle control units, even inverter and motors. So we work with industrial partners to develop the whole system. We are also the first team to have the driving license to drive our autonomous driving vehicles on the real road. Now we have different types of autonomous driving vehicles. We also export these technologies to international partners, such as in Japan. Now we have high-definition map technologies. And in Australia, we now can drive a 35-ton truck on the highway in Australia. That's for ground vehicles. In the air, now we also have unmanned aerial vehicles. We target more on the high payload, specific application, UAVs. Over the past few years, we have developed flight control technologies, high power motor generating technologies, and also integrate into the system with different payloads and applications. In many developed countries, railroad transportation is a good means to transport from one place to another. So we have helped our railroad companies to develop a BRT tester, platform screen doors, also intelligent inspection vehicles for railroad track, and automatic painting factories. So we target more on the operational or maintenance systems for railroad transportation. So with this, I give you a quick overview of our capabilities. So if you are interested in any of the technology, feel free to contact us. Thank you.
Thank you, Dr. Yang, for your inspiring sharing. Firstly, we would like to explore the innovative sphere of vehicles. Let's welcome Ning Chao Zhang to talk about RV Reducer.
Hello everyone, my name is Lin Chaochang, and I'm from the Mechanical and Mechatronic System Research Laboratories at the Industrial Technological Research Institute. As an engineer, I'm dedicated to drive innovative technological advancement. Today, I'm honored to introduce our design and analysis platform for RV reducers. This platform integrates industrial experience with our team's engineering capability and serves as a key tool in advanced smart manufacturing and precision applications. Let's first take a closer look at the core structure of the RV reducer. This slide shows the internal configuration, which consists of two primary transmission stages, a cyclic gear stage and an involute planter gear stage. The input is provided by a sound gear that drives 2 to 4 planter gears. Each planter gear is mounted on the crankshaft, which then drives a cycle disc in a circular motion. This design not only enables a high gear ratio, but also achieves multiple gear mesh engagements simultaneously, significantly improving load capacity and transmission stability, both of which are critical in high load and high precision applications. Next, let's look at an exploded view. It provides a clearer picture of all the critical components of the RV reducer. Each precision machined part is designed to work in perfect coordination with others, forming the backbone of the RV reducer's outstanding performance. We have developed a dedicated RV reducer design and analysis platform. It includes basic and geometric parameter setting, curve visualization, and grinding wheel profile generation. With this platform, we can significantly reduce development time while ensuring the reducer meets the performance demands of the market. On the slide, highlight several key advantages and features of our RV reducer development. First, in terms of transmission accuracy, our RV reducer achieves a backlash of less than 1 arcmini, which is much better than the industry average of 2 to 4 arcmini. This is critical for high-precision applications. Second, we possess the ability to systematize and marginalize the design and manufacturing know-how. From modeling and process parameter definition to customized application integration, we support the needs of the vertically integrated manufacturing systems. Lastly, we have implemented a performance verification process for the RV reducer, covering critical metrics such as torsional rigidity, backlash, and load capacity. This ensures the actual performance matches the design specifications. These three advantages form a solid technical foundation that is reliable, controllable, and measurable, essential for smart system integration and advanced manufacturing. With these core advantages in place, let me now walk you through the comprehensive service we provide to support RV reducer development. We outlined the three core domains of our technical support: design and analysis, manufacturing and assembly, and verification and validation. In the design phase, we provide parametric gear modeling, tolerance evaluation, structural stress analysis, and motion simulation, laying a solid foundation for performance and manufacturability. In manufacturing, we support process planning, fixture and tooling design, and precision inspection of components, ensuring production efficiency and quality consistency. Then, in the verification phase, we conduct detailed performance testing on key metrics, such as transmission error, backlash, efficiency, torsional rigidity, and startup torque. This ensures the final product aligns with both the original design intent and the demands of real-world application. Altogether, this full-spectrum service reflects not only our technical depth in RV reducers, but also our strong commitment to reliability, quality assurance, and full life cycle partner support. Our RV reducers serve as critical components in the automotive industry, particularly in electric vehicle and autonomous driving systems. They are also well suited for automotive equipment, such as seaport hoist and automotive guided vehicles, which demand both high precision and high load-bearing capacity. With the growing global demand for green energy, our RV reducer also showed great potential in the wind power industry. We firmly believe this technology can bring revolutionary improvements in efficiency and code effectiveness across various sectors. In summary, the RV reducer design and development platform from ITRI not only enhance reducer performance but also represent a vital step toward intelligent, efficient, and integrated industrial solutions. It embodies our strong commitment to technological innovations and engineering excellence. We look forward to establishing strategic collaboration with partners from various industries, exploring the limitless possibilities this technology can offer, and embracing future challenges in industrial application together. Thank you for your attention, and I'm open to any question you might have.
Thanks, Ning Chao, for an incredibly informative presentation. Now let's invite Uma to share advanced motor controller technology for electric vehicles technology.
Hello everyone, I'm Uma Shankar Raut, a hardware engineer at ITRI Mechanical and Mechatronics System Research Lab. Today I am excited to share how our advanced motor controller technology powered by silicon carbide or SiC are reshaping the future of electric mobility. In the next few minutes, I will walk through our journey of compressing kilowatts into liters, minimizing energy losses, and accelerating time to market for our partners. Let's start by looking at our roadmaps that making 100 kilowatt liter per power density a real possibility in 2025. Here you see the complete EV powertrain. The charger brings the grid power, the battery stores that energy, and motor controller convert DC to controlled AC to drive the motors. The motor controller is what our team focused on. In 2020, our inverter achieved 20 kilowatt power density. By 2023, we improved that to 60 kilowatt per liter using SiC technology, better thermal design, and optimized layout. Our next goal is 100 kilowatt per liter by 2025. We are making it happen by using next generation silicon carbide devices, replacing film capacitor with high density ceramic ones, adopting compact liquid cooling systems, and integrating PCB based Rogowski coil for current sensing. This results in smaller, lighter inverter, freeing space, reducing weight, and improving vehicle range. Even better, our design scales seamlessly from 6 kilowatt to 250 kilowatt, enabling adoption across e-scooter, sedan, truck, and buses. Now, let me take behind the scene how we make sure every motor controllers work right the first time. We begin with detailed 3D multiphysics simulation to analyze the heat magnetic flux and electrical stress. We tweak the design until it meets thermal and loss limits. Next, we built the prototype and run the double pulse test to assess the switching losses and voltage overshoot in real circuits. In hardware in loop testing, we connect the controller to real-time simulator emulating a motor. This allows us to run thousands of fault cases safely and efficiently. In vehicle dyno testing, finally the controller is mounted on real vehicle in our dyno lab to evaluate the efficiency map, acoustic noise, thermal rise and system response during the actual drive cycles. Each stage helps us catch potential issues early, reducing prototype iteration, saving times and cutting costs. Quality is our promise. We operate 4 specialized labs, virtual vehicle labs, validate the control algorithm across millions of virtual kilometers. Power labs measures efficiency, EMI and transient voltage behavior. Battery and charger lab ensure communication reliability across chargers, BMS and environmental extremes. Vehicle lab execute complete vehicle validation, vibration, splash water, dust and shock. We also follow a strict pre-test checklist, cable torques, sensor calibration, emergency stop mechanism, proper fuse settings. For endurance, we test the inverter at 85 degrees Celsius for hours, subject them to hours of multi-axis vibration, excess corrosion in salty spray chambers. Thanks to this rigorous process, our field failure rate is too low, ensuring low recalls, longer uptimes and happier drivers. We follow modular design philosophy. Power module blocks contain SiC switches, DC bus block integrate high density ceramic capacitors, gate driver blocks control each switches precisely, control board execute the advanced motor controller algorithms. This block based approach allows us to serve multiple vehicle classes from 6 kilowatt scooters to 250 kilowatt heavy duty trucks, all using the same scalable architecture. Our firmware is equally flexible. It auto detects input condition and scales control gains automatically. This results in faster development for OEMs, lower the BOM costs through parts reuse, simplified maintenance, one code based support multiple vehicle types. To conclude, what you have seen today is a journey of engineering precision. We have combined SiC technology, compact power design and rigorous validation to deliver compact, reliable and scalable motor controller solution for EV industry. We welcome partners ready to join us in pushing the boundaries of what electric vehicle can achieve. Thank you for your attention. I'm open for the question now or happy to discuss detail with you after the session.
Thanks, Uma, for nailing every aspect of your presentation. Next, let's invite Yuanjie Luo to share HolonRobotics, unified intelligence for AI robots in manufacturing.
Imagine a future where the robot is not just a tool, but an intelligent partner, one entity that can continuously learning and self-evolving. Hi, I'm YC, the CEO and founder of HolonRobotics. We are building the first AI robotics software capable of standalone intelligence and unified knowledge. HolonRobotics is a software company. We preserve industrial knowledge through AI. We preserve manufacturing knowledge through automation by unifying AI, robot, and sensors, making intelligent manufacturing a reality. We have 7 experts across robotics R&D, finance, marketing, and operation, combining technical depth with business execution. After 4 years incubate in ITRI, we are officially spin off this year and close 0.5 million angel round. As labor shortage is serious and happen around the world, in manufacturing, company lost up to 10 million revenue when their senior engineer retire or exits. In metal processing, it's much more urgent. The median worker age is 51, the highest among 80 other industries. So, after 30 years automation, what holding it back? 3 reasons. Industrial robot has been limited to mass production, requiring specialized expertise, complex programming, and manual adjustment. First, hard to learn. Manufacturers need to at least 2 years to train a robotics engineer, making skilled labor a major barrier. It's especially difficult because we are facing labor shortage issue. Once they leave, the knowledge goes them. Second, time-consuming. Developing, testing, and validating a robotics automation project take 3 to 6 months to ensure production feasibility, making the process highly time-consuming. Third, rigid. Even after deploying the robotics automation in production, every changeover needs manual reteaching and adjustment. The knowledge is hard to transfer, making robotics hard to use in today's fast-changing manufacturing need. So, we envision the robots not as a tool, but an intelligent, self-evolved partner. That's why we built an AI-driven operating software with a human-in-the-loop approach. It allows the robot to learn directly from the operators and turn the experience into intelligence. We make robots that don't just do tasks, they understand how to do tasks. To do that, we simplify the process to save 85% of the time. Meanwhile, our solution can continuously learn from the operator's experience. Eventually, will lead to 30% boost in productivity. To achieve this two goals, we designed two products for each purpose. We built two integrated products, HolonOS and HolonClouds. The idea is like iOS and iCloud work together. HolonOS, control panel, a complete hardware and software solution designed for instant execution and rapid response for robots and sensors. HolonCloud, a cloud-based platform for deep learning and centralized intelligence, enhanced AI-driven for robotics and sensor. HolonOS, an edge AI control panel featured with, first, unified interface. It eliminating the sensor and robot integration time. Supports leading robot brands like Fanuc, ABB, Yaskawa, KUKA, and Mitsubishi. It integrates 2D vision, 3D vision, laser line scanning for sensor, active force control, PLC, and I/O modules, all to saving the integration time. Second, cat-free patch generation engine with just 3 simple steps: scan, patch generation, and deploy. Simply place the workpiece and the 3D scan automatically sensing its geometry. User can interactively adjust and generate the robot path. Seamlessly deploy in a unified interface, eliminating the needs for CAD model or manual teaching. Last, an edge AI. That's how our HolonOS can learn and improve direct from the first-hand data, based on any operator intervention that make the robot actually learn from the human. HolonCloud, a deep thinking and learning service AI code generation. Generate the robot code from the process idea in minutes, saving programming time. It creates accurate robot program based on process requirements. And it also acts as an AI assistant, answering technical questions instantly. It's embedded with system knowledge, including maintenance manual, operation guides, mechanical and electrical diagram, ensuring precision and efficient support, saving the troubleshooting time. Our go-to-market strategy is simple and clear. We direct bring value to the end user to save time and increase productivity. Collaborate with system integrators to accelerate the deploy and amplify the word to mouth. Once we achieve the product market fit, we will scale through distributors and key suppliers to build a global sales network and scale rapidly. Today, HolonRobotics has delivered 15 successful cases across 9 industries, with $800,000 in revenue, which are medical, cutlery, defense and grinding, one of the largest cutlery, heavy machinery manufacturers, and kitchenware company. Also, we co-marketing with industrial leaders, including Fanuc, Mitsubishi, Neurosys, and the NVIDIA in Session program. One of our success stories is in cutlery industry. Changeover in cutlery manufacturers are a real headache. Parts are never perfect. Usually, means tedious manual adjustment because of an avoidable preprocessed workpiece difference. HolonOS, paired with a laser line scanner, it will automatically measure each workpiece geometry and generate exact grinding path to removing the setup time. Now, customer can swap between 50 plus products types on the same line and already process over 300,000 parts with 30% of a productivity increase. Same issue happened in the motorcycle and fitness bike industry. The unavoidable preprocessed workpiece difference, HolonOS, with a laser line scanning, capture each part's dimension and auto-generate precision grinding and polishing path, cutting setup time to minutes. The intuitive parameter interface that can turn complex adjustment into a few clicks, ensuring smooth production and consistent quality. So if you're excited about a future that robots should not just be a tool, it's actually an intelligent partner, we love to connect.
Thanks, Yuan Jie, for your comprehensive sharing. Ladies and gentlemen, thank you for joining us today. Before leaving, let's invite Dr. Yan back for some closing remarks.
As today's forum concludes, I thank you for being a part of this deeply insightful and enlightening online forum. Our collective passion for innovation and dedication to reshaping the future of manufacturing and mobility have made this an exceptional exchange. Let this forum serves as a stepping stone towards forging new partnerships, fostering innovation, and nurturing the growth of intelligent mechatronics in the manufacturing and mobility sectors. I encourage you to stay connected, continue to exchange ideas, and explore opportunities to collaborate. Once again, thank you for your active participation, and I look forward to meeting you again in the future.
Thank you, Dr. Yan. Indeed, we look forward to stay connected with our audience and for the future collaborations. For those who haven't had the chance to share your feedback, we will leave the QR code on for a few minutes after the event. We have also shared the survey link as well as an email in the description below, so you may write us with follow-up questions that we didn't get the chance to answer today. Thanks again, and we look forward to staying in contact.